This is one of those videos that's going to help us solve an integral, but we're not quite there yet. So let's learn this pre-knowledge. The question is, how can we label two sides of the triangle so that one of the sides is the square root of x squared minus 9? And so I'm trying to get basically a match right here. I'm trying to get one of the sides of the triangle to be that, and then I have to determine the other two sides. Well, just as a reminder, we should know with Pythagorean theorem that the leg squared plus the leg squared equals the hypotenuse squared. And so if I'm solving for a leg, okay, I'd have leg squared equals hypotenuse squared minus leg squared. See, all I did was subtract leg squared from both sides. Okay, and then I would square root both sides to solve for the leg. So I'm going to square root this and square root that. So I get a leg is equal to the square root of a hypotenuse squared minus a leg squared. And that is so helpful here. We're basically saying, how can I have that match an x squared minus 9? Well, can I rewrite this as the square root of something squared minus something squared? Yeah, you certainly can. It would be an x squared and then minus a 3 squared. So I just determined that one of my legs, sorry about that, one of my legs right here is going to be a 3, and my hypotenuse is going to be an x. And that would force this side right here to be the square root of x squared minus 9. Now I'm going to assume that you don't believe me, which you may not. Let's go ahead instead, let's let this be equal to y, and let's solve for y right now. So we're going to have 3 squared plus y squared equals x squared. That's going to give me a 9 plus y squared equals x squared. Subtract 9. I get y squared equals x squared minus 9. Square root both sides, and I get y is equal to the square root of x squared minus 9. And that is that perfect match. We've answered the question, how can we label two sides of the triangle so that one of the sides is the square root of x squared minus 9? So we label it with an x here and a 3 here, and that forces this y to be that x squared minus 9. All right, let's do another one. Okay, this time here, notice that there's a plus, and I'm going to actually start this a little different. I'm going to say that leg squared plus leg squared equals hypotenuse squared, and I want a plus in my thing, so I'm just going to go ahead and square root both sides. So I get the hypotenuse is going to be equal to the leg squared plus the leg squared. Meaning, can I rewrite this so that the leg is something squared and the leg is something squared? Forgot my, nope, there's no squared. All right, so what is that going to be? Well, what is the, if I want something to be 25, well, that's going to be 5 squared. And if I want it to be x squared, that will be an x. So that basically means that my leg is a 5 and my leg is an x. And you could have rearranged that as the 5 on the top and the x on the bottom. Now let's go ahead and check that by letting this be equal to y. So we'll have x squared plus 5 squared equals y squared. That's x squared plus 25 is equal to y squared. Square root both sides, and I get y equals the square root of x squared plus 25. And of course, I can go ahead and rearrange that. And that would just be 25 plus x squared equals y, and I do have a perfect match. So this is going to go ahead and be a 25 plus x squared. And I've done it. I've essentially drawn a triangle with two sides such that one of my sides is a perfect match with this. Let's do one more. All right, in this case I have a subtraction. So let's go back to my leg squared plus leg squared equals hypotenuse squared, and I am going to subtract. So I get a leg squared is equal to a hypotenuse squared minus leg squared, square root both sides, and I get that a leg is going to be equal to the square root of a hypotenuse squared minus leg squared. So this is going to be my hypotenuse. In other words, I'm going to have a 3 as my hypotenuse, and then I'm going to have an x as a leg. So my 3 is my hypotenuse, and an x is my leg. And if you want to check this, you can. Let's let this be y. Let's check that x squared plus y squared equals 3 squared. That's going to give me x squared plus y squared equals 9. That gives me y squared equals 9 minus x squared. Square root both sides. We get y equals square root of 9 minus x squared. And that's exactly what I wanted here. Sweet. So if we were going to memorize something like this, let's go ahead and look at the 3 cases. The first case is when we have a subtraction. When we have a subtraction, this is going to be your hypotenuse squared minus your leg squared. Okay, and if you see on the last problem, this is the same thing here. This will be your hypotenuse squared minus your leg squared. And then that's why I labeled my hypotenuse as 3 and my leg as x. Similarly, that's why I labeled my hypotenuse as x and my leg as 3. However, when I have a plus, it really means you're solving for your hypotenuse, and so this would end up being a leg squared and a leg squared. And that's when the plus is the case. And so my leg here would be 5, and my leg here would be x, because we're squaring it, right? And then your hypotenuse would be this match right here. All right, that's kind of an abstract topic, but I feel pretty good about it. I hope you do too. Thanks for watching.